This is the Chapter 11 practice test. I'm going to attempt to turn it into an ed puzzle, especially for the kids who were gone today for the field trip. So let's get going. Number 1, the square root of 324 is, I asked you guys to memorize these, so you should know, 13 on through 20 squared, 13 squared, 14 squared, 18 was one of them. And square root of 324 is 18. Okay. Let's go on to the next one. Okay. Is 5,625 rational or irrational? Well, to figure that out, we have to really figure out if it's a perfect square or not. 5,625. So the first thing I'm noticing is we have to go through our divisibility rules. Is it divisible by 25? Is it divisible by 9? Is it divisible by 4? Well, it's divisible by 9 because 5 plus 6 plus 2 plus 5 is 11 plus 2 is 13 plus 5 is 18. So that's divisible by 9. But I see it ends in 25, so this has to be divisible by 25. So let's first figure that out. So it's 56, 25. Let's see if it's divisible by 25. It goes 2 times. That's 50. And so 6 minus 0 is 6. I bring down the 2. It goes another 2 times. It's 50. And then I have a remainder of 2, and I bring down the 5. 25 goes into... Oops, 1. I forgot that. So how many quarters in $1.25? There are 5. And so really what we have here is 5625 is made up of 25 times 225. And the square root of 25 is 5, and the square root of 225 is 15. And when you multiply those out, 5 times 5 is 25, carry the 2, it's 75. So the answer is 75. So since the answer is 75, actually, the question is 5625, the square root of 5625, rational or irrational? Since it's a perfect square, it is rational. Remember, non-perfect squares are irrational and perfect squares are rational. And we now know, to simplify it, it is 75. Now, determine the values for x. If x minus 9 in the square root of x minus 9. That means, what does x have to be so that we don't get a negative? Because the big rule of square roots is you can't take the square root of a negative. So where do my negatives end and begin? They end at 0. So we take whatever's in here and set it greater than or equal to 0. Because if it equals anything less than 0, it'll be worth a negative. So I take what was in there, which was x minus 9, and I set that. Okay, so whatever's in there, if I get 2x plus 5, I set 2x plus 5 greater than or equal to 0 because it can't equal a negative. And in this case, for the problem on the practice test, I add 9, we get x is greater than or equal to 9. So the solution is, it's any number greater than or equal to 9. Greater than or equal to, 9. All right, if it were something like this, I would set 2x plus 5 is greater than or equal to 0. Subtract the 5. And I have 2x is greater than or equal to negative 5. Divide by 2, divide by 2. X is greater than or equal to negative, that is 2.5. So it could be negative 2. If x is negative 2, right, 2 times negative 2, it still gives me a real number. It's 4, negative 4 plus 5, that's still equal to the square root of 1, and that would be 1. So it doesn't have to be a perfect square, I can't have a negative under the radical. So it could be negative 2, it could be negative 1, it cannot be negative 3. It has to be greater than or equal to negative 2.5, okay? So we did have one exception on the quiz where there was something squared, and if you square anything. All right, now over here it doesn't mention anything, assume all variables are non-negatives. So when I'm doing, I don't need to say this. Okay, so when I'm doing the square root of 64b to the 7th, I'm going to break that down. 64 b to the 7th gets broken down to 64. The closest even amount is b to the 6th, rad b. Okay, the square root of 64 is 8. The square root of b to the 6th is b to the 3rd, and what's left under the radical that is not. Now, would I use my absolute value? The only time we use it is if we have an odd result all alone. So no, I would not do it because there's a b here and a b here. We don't use absolute value. So answer is 8b3, 8, b to the 3rd, rad b. Now, if I have square root, the next one, y minus 3 squared, when I take the square root of that, I end up with a binomial that's y minus 3 to the first power. Since that's an odd result all alone, we are going to put that binomial into the absolute value. So if it's an odd result exponent all alone, it goes into the absolute value. Make sure you have that written down. Pause it if you need to, because I'm about to erase and go out of writing mode. And go up through the next few. Okay, now, number 7. So here we go. Number 7 is made up. I would break it down. Number 7, we're going to break down to is the square root of 1200. Square root of 1200. We can do 100 times the square root of 12. And I can break down, I know that this is going to be 10, and I can break down that 12 to 4 times 3. So I get 10. The square root of 4 is a 2, and then I'm left with rad 3, so that's 20 rad 3. 20 rad 3. Okay? Again, you are getting credit for the work, not necessarily the answers, okay? So the next one, negative 3 times the square root of 98c squared. Now, a lot of the kids told me, like, oh my God, this is so scary, but just start, it's an even number, so start dividing it by 2. And when you do that, you see you get 49 times 2 times c squared. Negative 3 times 7, right? The square root of 49 is 7. 2 stays under the radical, and c comes out. Square root of c squared is c. Now, when I simplify that, I get negative 21. Notice there's no other c's, so that is going to go into the absolute value, and then I have rad 2. So that's negative 21 absolute value of c, and then we have a rad 2 still under the radical. Now, from number 9 on, it says assume all variables are non-negative. Once they say that, we don't have to do any absolute value. So here we go. I'm doing y plus 16. It's under the radical. This whole thing is to the 9th. We have to break that down to y plus 16 to the 8th power, the closest even, to y plus 16 to the 1st power. The square root of this is y plus 16. I have to keep it in here because it's to the 4th power, and under the radical is still the y plus 16 to the 1st. So my answer is this. Now, if you don't use the parentheses, it would be wrong. So if I'm just going to write y plus 16 to the 4th, rad y plus 16, because all of this is to the 4th power. Got it? Number 10. is 6ac times 6ab. 6ac, 6 times 6 times a squared times bc. Well, we can pull a root out of 6. I can pull an a out, and what stays under the radical is bc. I don't need absolute value, so it's 6a rad bc. Okay, next one. I'm going to erase what's in the middle here. You should be doing yours on paper. It's harder for me to have it on the paper and what we are doing for videotaping purposes. Okay, 6 times 18. A couple different ways we can do this. If I have the square root of 6, right away I am noticing that 18 is made up of 6 times 3, right? So right away I can pull a 6, because 6 times 6, all under the same radical, and then I'm left with rad 3. 6 rad 3. Some people did the square root of 6 times the square root of 9 times 2. Well, that's fine. I can pull the 3 out of there, but then I'm still left with that 6, and in the 6, it's made up of 3 times 2, and I have this other 2 here, right? So together, I can pull another 2 out. 3 times 2, and I'm left with rad 3. So that is 6 rad 3, okay? Either way, it doesn't matter how you did it. There's no right way or wrong way. Okay, let's go on to the next one. 27. Next one is 27. C to the third. Okay. 27. Altogether, I've C to the fourth. And D is to the 8th. So I'm breaking down 27 to 9 times 3, C to the 4th, D to the 8th. That makes a 3. I can pull out C squared. I can pull out a D to the 4th. And what stays under the radical is 3. I don't have to do absolute value because it says assume all variables are non-negative. So it's 3c squared d to the 4th rad 3. Okay? Pause the recording if you need to write this down. Okay, 13, 14. Okay, 13 is, altogether, we're going to add these up. So I've got 42, 27, and 31. So that's 10, carry the 1, 4, 5. 5 is 10. So this is really the square root of y to the 100th power. What is that? Remember, it's really every 2. So we have to divide it by 2. We end up with y to the 50th. So number 13, a lot of people get tricked by that, y to the 50th, okay? They want to say it's y to the 10th, but it's not made up of, it's made up of 50 y's, and every 2 make a perfect, it's made up of 100 y's, and every 2 make a perfect square. Number 14, we've got a negative 1 times the square root of 9 over the square root of 49. So negative 1 times the square root of 9 is 3, all over the square root of 49 is 7. So that makes negative 3/7. I could take the negative in the denominator too. Okay. 15. I can reduce first, or I think I'd like to reduce, or it will be too big. So when I have 15 over 60a squared, first of all, 15 goes into 15 once, and 15 goes into this 4 times. So really, what does this equal is the square root of 1 over the square root of 4a squared. And that is a perfect square. The square root of 1 is 1, the square root of 4 is 2, and the square root of a squared is a. So answer is 1 over 2a squared. Okay. Please write this down if you need it. I'm going to be erasing. Here we go. We're going to divide and simplify. So we can divide under the radical if we want. Since this divides evenly, 64 divided by 8 is 8. And then I can break down 8 to 4 times 2, which equals 2. The square root of 4 is 2 times 2. Next one. I'm pretty sure 16 goes into 400. So, here we go. Let's go. Let's see if 400 is divisible by 16. It is, or I can just do this. Actually, since I don't know and I would need a calculator, then what I think I would do is the square root of 400. I can do this, 400. And this right away, I know I can get rid of 1, and so this is a to the 8th. So square root of 400 is 20, right? Is 20. The square root of a to the 8th is a to the 4th. I've already canceled, since there's 1 in the denominator, we can cancel 1 out of the numerator. And the square root of 16 is 4. And so what does that simplify to? 5a to the 4th. I could have also divided 400 by 16, and it's 25. A to the 9th minus 1, dividing out 1 would be a to the 8th, and that still is equal to 5a to the 4th. Same answer, 2 different ways to do it. I divided this. All right? Let's move on. I'm going to move this up because I do need some more room. Okay, 2 rad 6 plus 3 over rad 6. Oops. 2 rad 6. Wow. There we go. 2 rad 6. Okay. We are doing 2 rad 6 plus 3 over rad 6. So the first thing I think I'd like to do, I'm going to remind you that when we add fractions, we have to have a common denominator. But instead of multiplying by a radical on the left side, I'm going to first get rid of my radical. We also have to get rid of all radicals in the denominator. So to do that, I would have to multiply it by rad 6. And so the only way I can do that is with this fancy one of rad 6 over rad 6 using the identity property. So now what I have is 3 rad 6 all over 6. Okay? And then over here, I've got 2 rad 6 over 1. Like, what would I need to multiply to give that a common denominator? So since 6 is the other denominator, I'm going to need to multiply this by 6 over 6. So that becomes 12 rad 6 all over 6. Now my denominator is the same. We can add the numerators. So 12 rad 6 plus 3 rad 6 makes altogether 15 rad 6 all over 6. Now we have to simplify the non-radicals, and they're both divisible by 3. So 6 divided by 3 is 2, and 15 divided by 3 is 5. And so we end up with 5 rad 6 all over 2. 5 rad 6 all over 2. Okay, next one is rad 9 over 10. Rad 9 over rad 10. So I think I'm going to get rid of the radical in the denominator. Rad 10. There's no perfect squares in it, so may as well get rid of it. And we get rad 90 all over 10. Okay? The 2 rules here are leave no radicals in the denominator and leave no perfect squares under the radical. So under 90, 90 is made up of 9 times 10. There's that perfect square. and then I have a 10. So the square root of 9 is a 3. I'm keeping the 10 under the radical, and I cannot simplify my non-radicals. So it's 3 rad 10 over 10. 3 rad 10 all over 10. Okay, next one. Oh, this is a lot easier than it looks. So 3 goes into 3 once and into 21 7 times. We simplify our non-radicals. Now, first I simplify the non-radicals. Now, 60 divided by 15. 60 divided by 15 is 15 goes into 15 once, and 15 goes into this 4 times. So it's the square root of 4 over 7 times square root of 1, which is 1. And the square root of 4 is 2 over 7. Sorry, not rad 7. It's just over 7. Okay? I could have multiplied by rad 15 over rad 15, but it would have taken too long. Oh, whoops, I've got my numbering wrong. So this is 18. This is 19. This is 20, is 2 over 7. 21, 6 rad 12. 6 rad 12. 10 minus 10 rad 27. Actually, let's just do this. 6 rad 12 minus 10 rad 27. I hope that's right. Plus 3 rad 12. And then I have minus 2 rad 27. Okay, let's simplify under the radical. Before we know if we can combine like terms, we have to see if they're the same, what they simplify to. So 6 stays the same, but this is going to be 4 times 3. And that reduces to, I can pull a root, 6 times 2 rad 3, right? So that's 12 rad 3. Minus 10 times 9 times 3. That's minus 10, I can pull the root out, times 3 rad 3. So that's minus 30 rad 3. Plus 3 times 4 times 3. 4 is a perfect square, so I can pull it out. And then we have plus 6 rad 3. So far, so good. They're all rad 3s, so they're like terms. And then the last one is 2. I have to break down 27 to 9 times 3 minus 2 times 3 times 3, right? It's a pull a perfect square of 3, and we get minus 6 rad 3. Now notice right away we have additive inverses. These are going to cancel out, so I'm really left with 12 minus 30 because they're both rad 3s. 12 minus 30 is negative 18, and I'm still left with rad 3. Okay? Was negative 18 rad 3. And that is number 21. 22, rad 125. Okay, I'm going to go here. Rad 125. Rad 125, and then it was 3 rad 45. 3 rad 45. Can't remember if it was plus or minus. Plus. Okay, we have to break them down, pull out the perfect squares. So up here I've got 25 times 5. And that simplifies to 5 rad 5. Plus, now 45 has the perfect square of 9. So that's 3 times 3 times rad 5. So that's 9 rad 5. And this was a 5 rad 5. So now we're just adding the coefficients because they're both like terms. So how many rad 5s do we have? 9 and 5 is 14 rad 5. 14 rad 5. Okay, 23. Oops. 23 is 1/4 rad 48. 1/4 rad 48. 1/4 rad 48. And then I have plus 48 rad 3/4. Okay, so I'm going to just multiply this out and put them all over. So we really have rad 48 over 4 plus 48 rad 3 over rad 4. Well, we know that this is going to be 2. And you know what? I want to break that down, that 48 in the first one, down to 16 times 3. So that really becomes 4 rad 3 over 4 plus, over here, I have 48 rad 3 over 2. I'm going to have to multiply this by 2 over 2. Okay, we can't add it until our denominators are the same. So then what I get is 4 rad 3 over 4 plus 2 times 40 is 80. 2 times 8 is 16. So that's 96 rad 3 over 4. Let's add them up. We get 100 rad 3 all over 4. And 4 divides evenly. We're going to divide out our non-radicals. It goes once, it goes 25. And so we are left with 25 rad 3. Just about done with the ones that we can do. Let's see. Oops, let's go back there. 25. This is 22. And this 23 is 25 rad 3. Okay. Let's see. Almost done with this. Okay. 20-foot ladder. So we have two Pythagorean theorems. Okay, a 20-foot ladder against a building. So the ladder against the building. The wall touches 16 feet. It's a 20-foot ladder. How far is the building from the bottom? Right? That's our x. So we're doing a squared plus b squared equals c squared. We're doing 20 squared. Nope. What is my hypotenuse? Remember, our hypotenuse is always opposite the right angle. So 20 squared has to go here, 16 squared here, and x squared here. So x squared plus 256 equals 400. Subtract 256. Okay, 400 minus 256 is 144. Isn't this nice? X squared equals 144. Don't be rude, just root it. So we have, it is, x is equal to 12 feet. The ladder is 12 feet from the building. Okay? Next one. When you're doing word problems, you should be estimating if it's not a whole number. So they said we are driving 20 miles east. Okay, that's like on my map. I'm going 20. And then I go 15 miles south. Here we go. Okay, how far are we from the original starting point? So again, it's a squared plus b squared equals c squared. It's 20 squared plus 15 squared equals c squared. 400 plus 225 equals c squared. It's 625 equals c squared. Don't be rude, just root it. And we have 25 is equal to c. So it will be 25 miles from the starting point. And for now, that's all I'm going to do. I'll cover the next 3 in class tomorrow.